Okay, great. So, hey everyone, my name is Veronica Ray. I'm currently in Brooklyn right now, and this is about preparing for the SwiftUI future. I gave a talk at Swift Toronto last year called Pushing SwiftUI to the Limit. And that was about taking a small, isolated, custom UI component and migrating it to SwiftUI. And this was to see what SwiftUI was capable of, whether it was, faster and easier to develop with. And I saw some amazing things in terms of how much time and code it took to do the original component versus the SwiftUI version. And so I'm sure we're all, trying to get our heads around SwiftUI. I'm sure, some of you all are working on side projects. And this talk is more about applying what you're learning to what you're doing at your job, both in what you can do right now and also how you can make a plan and a migration strategy and get others on your team on board. The first step is preparing your code base. So this is an example of something you can do right now. One thing that folks have been talking about a lot is the right app architecture for SwiftUI. Do the current app architectures work? Are they still relevant? So I would say that there's 3 main architectures that are contenders right now. Flux and the composable architecture are very similar. So really there's MVVM and there's Flux. Those are what I would encourage you to look at. So I've been at home for the last month or two, and I started playing Animal Crossing. So my favorite thing about Animal Crossing is all the custom outfits that you can download. And these outfits are found using creator IDs. So you can find creator IDs on Reddit or YouTube or Instagram. They're all over the place, and they're this like long string of numbers. And you have to type them into the game, and then you can download the outfits these creators have made. So I started building this app because there's no way to save these IDs in the game. And I thought it would be great to not only save the IDs, but also, tag the creators, maybe show some screenshots of their style, the name of the creator, and, eventually maybe even ways to financially support that creator. So this is my current favorite outfit. If anyone is into designer fashions and wants to type in the channel what designers they think this outfit represents, please share. I'd happy to see, if someone can guess correctly. So MVVM is probably the most, familiar to most of you all. And it's the new MVC, you could say. It's, like the default choice for SwiftUI. It's what you're seeing in the WWDC videos. And many UI kits are already using this architecture successfully. We currently use an MVVM architecture at Compass. I've actually used MVVM architectures at LinkedIn. And, when I was there, we were not using functional reactive programming. It was more of a delegation-based approach. And so you can use MVVM with delegation. You can use it with functional reactive programming. And it's a fairly natural fit for SwiftUI. This is the architecture diagram, and it's really characterized by these two-way bindings and also, this nice separation of concerns. And at Compass, we try to move as much logic to the view model as possible. And that's where we are unit testing. And so we have this clear separation of concerns, and we also are, doing a lot of unit testing of our business logic in these view models. One area of interest that we've been talking a lot about at Compass is managing state. For example, I work on the search feature, and we have this search query class that represents everything about the user search. It could be neighborhoods, it could be price filters, it could be, so much more than that even, like the viewport on the map. And we are updating the state of this search query all over the app. Some places we're making deep copies of the search query because that's what we need to do. In some places we're not. And so the mobile team as a whole has been thinking a lot about how to better manage state. And that's where the flux pattern comes in. You might have heard of flux, redux. Those terms are often used interchangeably. Flux is the name of the architecture pattern, and redux is a specific library that implements that pattern. So that's why I'm using flux here. The great thing about the flux pattern is that you don't need that much code to implement it. There are third-party libraries like ReSwift, but they're lightweight, they're small, they're really easy to adopt. So the core idea of the flux pattern is this unidirectional data flow. And also, you're not directly manipulating and updating the state. State can only be updated through this flow. And so your view is kicking off an action. The action feeds into the reducer. The reducer handles the action to update the store, and then updates to the store are represented in the view. A lot of folks in the community have been excited about the composable architecture. And this isn't really a separate architecture from Flux. It's very inspired by Flux. It follows that same architecture and data flow that I just showed, but it adds some new ideas, and it's more opinionated. It's also more heavyweight. And the exciting thing is that after a year of the point-free folks updating videos, like explaining this architecture, developing this architecture, they very recently released an open source library that you can use in your app. It has excellent documentation, excellent examples apps. They now have summary videos that very crisply, in 30 minutes, show you how to adopt this architecture. And I basically built my Animal Crossing Creators app using the SwiftUI Flux project, also using the composable architecture. And so I have a sense of, how these approaches differ. The composable architecture is essentially starting from the point of Flux and then saying, what are the pain points? How can we, improve upon this? One pain point that you'll hear a lot with the Flux pattern is performance. Views contain the data needed to render themselves and their children. And this is like a case study of what the point-free folks noticed. They noticed a performance issue in their sample app, and then they, explain very well in their videos how they refactor their code in order to avoid this performance issue. So where you're starting from is, I have this creator view. and it contains a store with the creator model and the creator action. And it's not containing, it's already, we're getting better because this store doesn't have the entire app state. It's really just the app state for the creator. But we can do better than that. So the composable architecture provides this with a view store initializer. And so you can really scope your store to just the data needed to render, what's really on screen right now. And this is how you implement it. And the really key idea here is that you're avoiding this over notification. You're getting notified when state changes that isn't on the view, isn't displayed on screen. And so instead of having this store as a whole conform to observable object, you're just having this view store conform to observable object. So this is one of many exciting and interesting ideas that the composable architecture is bringing to the table. Personally, from looking at these architectures and also knowing how the Compass mobile team approaches our architecture decisions, we're going to be going with something more lightweight. We don't want to pull in a big opinionated third-party library. However, I think the composable architecture is an excellent learning resource. It's incredibly high quality, and I think everyone here should check it out and support the point-free folks who are making these incredible learning resources. So the next step here, we're talking about a year from now, even later or earlier, with really depending on your specific situation. So once you go iOS 13 only, I would recommend you write all new code in SwiftUI. Now, this is a fairly optimistic and bold statement to make, because if you've been using SwiftUI right now, it's missing important features like collection views. There are definitely missing features. From what I've heard, it's not a good choice for a production app right now. But I feel optimistic that next year it'll be ready. And if it is ready, then I think that most teams will want to write all new code in SwiftUI. This has the benefit of avoiding a big rewrite of the existing app. And you can also take advantage of the faster development speed of SwiftUI in new projects. But just like with Objective-C and Swift, now you need to master the art of interoperability. And I'm going to show some real-world examples from spikes I did in our production app later on in the talk. So this is an interesting area that I did some thinking about. So you're already doing functional reactive programming. You're using, an existing third-party framework. Can you adopt SwiftUI without Combine? So you can technically, and there's already open source projects for bridging. However, there's some major downsides to not adopting Combine, and let me go through those. So first off, Combine, like SwiftUI, is missing a good number of features. You can find online here through the Combine community GitHub project, they did a one-to-one comparison with RX Swift. And as you can see, there's a lot of missing operators. This may or may not be an issue. It depends on what operators you're using heavily in your app already. And if you're not using any of the operators that are missing, then this really, you know, there's no reason to not adopt Combine. The second issue with not adopting Combine is you're going to miss out on some amazing performance benefits. This is some benchmarking done by QuickBird Studios. And from what I've seen across the board, Combine is just from the ground up designed for performance. It will just give much better performance than any of the FRP libraries out there. The last reason why not adopting Combine is an issue is one that is easier to overlook, but I have some personal experience in terms of how hard it was at my first job when you don't follow like the standard stack. So for example, I used to do web development, and I worked on an app where we did full stack web development in Java. We used a framework called Google Web Toolkit. Now, if you've also used Google Web Toolkit, please leave a comment so that we can commiserate. But the idea is you're writing your views in XML. We also used an object relational mapping framework that my boss wrote that literally nobody else used. And it was so hard to make progress on my own. We talk all the time about, you know, how you can Google for whatever you want and how programmers can, you know, make progress on their own. And it's really tough when you're working on a project where that isn't really possible. You can't really find other people to connect with who use your same stack or face your same issues. And I think, you know, using RX Swift with SwiftUI is not going to be quite so dramatic. But I think if you're a more experienced senior developer on your team, you need to be mindful of this. Maybe for you, translating that Combine example into RX Swift is going to be faster and more seamless because you already understand the underlying concepts. But a newer programmer or someone newer to FRP is not going to have such a comfortable, seamless experience. So please be mindful of that. I would say overall, unless you have a stellar reason to not adopt Combine, or you're doing like a phased migration approach, there's really no reason to not use Combine with SwiftUI. That's the intention. And you'll have a much easier time if you follow that stack. So the last idea here is the interoperability spike. So this is a great example of experimenting and using production examples in your app on a branch to understand what interoperability really looks like. What I have found from looking around is that there's a lot of hello world type examples for interoperability, a lot of great resources either in WWDC or folks in the community who are giving you the basic information you need to get started. But in order to do a real world example in the Compass app, I needed to experiment on my own and really dig deeper. So the first thing is that using SwiftUI Views within UIKit is easy. You might have seen this example of just initializing a UI hosting controller with your SwiftUI view as the root view, and it's great. You can use this as a view controller, or you can, you know, get its view. Very smooth, very easy. What is more complicated and requires writing more extra code is using UIKit within SwiftUI. And you might wonder, why would I do that? Well, a really stellar example is if you have a design systems library and you have reusable UI components throughout the app. The design systems team might wonder, do we have to migrate everything to SwiftUI on day one? That was a real question I was asked. And so I did this spike to see how much work it would be. This is on the left, a real screen in the Compass app. And on the right, I did a wireframe just because it's kind of hard. There's so much going on the screen. It's kind of hard to know exactly what I'm talking about. But you can see here, we have a very strange looking sandwich where you have the UIKit in this light green, and that's this image here. And it contains a SwiftUI view called a page indicator view. And that page indicator view has that nice little gradient background, and it contains a label. And that's our design systems component that wraps UI label. So the first step is that you need to create a representation that conforms to UI view representable. And so I created the struct label representation, and I created it in such a way that you could use this anywhere in the app. It's not tied to this specific use case. You have to add this make UI view function, and then an update UI view function. And this is, the simplest example. I'm not, really making use of the context here. It's really the most bare bones example that you can do. And so I'm just initializing this label, and then I'm saying, okay, we need to update the text. The second step is adding this UI representable struct to a SwiftUI view. So this is the SwiftUI page indicator view, and we just add in this label representation like we would add any other SwiftUI view. Finally, we're going to do the familiar and friendly step of initializing a UI hosting controller with the root view as our SwiftUI view. And this, it looks a little grimy because we're grabbing the root view, and then we're grabbing this model, this page indicator model, which is an observed object, and we're updating its index and its count. And so that's what's allowing, the correct notifications to be sent and the UI to be updated. So in summary, I have 4 key pieces of advice to send you off with. So now is the time to decide if you want to adopt a new app architecture. And now is the time to adopt that new app architecture if you feel comfortable adopting it with UIKit. MVVM is there's a lot of resources and already a lot of history around adopting MVVM with UIKit. There are definitely more performance concerns given how UIKit is implemented around adopting flux pattern. But the Composable architecture library actually does include UIKit example projects, and a lot of their ideas around things like view stores really help make it more viable to adopt their architecture with UIKit. So after you've already done preparing your app, maybe migrating to a new architecture, once you can go iOS 13 plus only, I suggest you write all new code in SwiftUI. And I also will highly encourage you to adopt SwiftUI and Combine together unless you have a great reason to not use Combine. I think if anyone is adopting SwiftUI without Combine, they'll probably regret that decision later. Finally, right now is an excellent time to do interoperability spikes in your production app and really understand well what your specific requirements will be. So it's been an honor to present at this conference. And yes, thank you for your time.